Hey everybody, I'm really excited to share this conversation with you guys today. It's with a guy named Chris Barton. He is a mechanical engineer and a CEO of a company called Drafter. We talk about his wide range of work experience, all the way from, working on a space plane to 3D printing houses. And then we get into his mindset and journey into entrepreneurship. I think his story is super interesting and I'm excited to share it with you guys. So let's get into it. Okay, so we are here with Chris Barton. He is a mechanical engineer and he's a CEO of a company called Drafter. I'm really excited to interview him, and I think everybody watching this should enjoy it quite a bit too because he has a pretty cool and interesting story. So, Chris, I guess take a second to introduce yourself.
Yeah, thanks for having me, Jake. Um, I'm Chris Barton. I am a mechanical engineer turned entrepreneur. I've spent my entire career building low volume, large scale things, and I'm currently the CEO and co-founder of Drafter, a software for hardware development company that is focused on improving the entire hardware development process, which is what I've spent my entire career doing.
That's awesome. I'm excited to get into that stuff. There's a lot of interesting things you just said that I think people are going to want to, dive into, which is what we're going to do. So let's just start at the beginning, man. So first of all, how long have you been working in industry?
Yeah. So let's see. I graduated in 2014 with a mechanical engineering degree, and I've effectively been a design engineer ever since. I spent the first few years of my career in the space industry. I worked on a space plane called the Dreamchaser, and then spent a number of years designing antennas for geosynchronous satellites. I'm a big space geek. Loved that period of my life, but wanted something a little more creative and to, find myself in a position where I could be more entrepreneurial. So I did some soul searching. Sorry, I'll pause there.
That's okay. Well, so let's go back a little bit. So like why mechanical? Why'd you go into mechanical?
Yeah, it seemed the most general. I wasn't sure what I wanted to do. I think my passion for the space world came in college. And so, leaving high school, I loved chemistry, I loved physics, but I didn't really know what I wanted to do with all of those. I had taken computer science, but wasn't necessarily in love with programming. And so, getting an engineering degree seemed like the logical next challenge, and mechanical seemed like it opened the most doors without, pushing me in a certain direction.
Sure. I think a lot of kids um, get stuck right there. A lot of people that watch this stuff are students and they get stuck right there where they're just like, I'm not necessarily passionate about one of the disciplines. And so they get kind of scared to choose one. But I think what you just said is important because it's like, hey, what pathway, what road gives me the most, checks the most boxes, right?
Hmm.
And usually it all works out just fine. Um,
I
that's
mean,
that's it. It was similar for me too.
the amazing thing of my graduating class of mechanical engineers, only a few of us became design engineers. A number of them became manufacturing engineers. A number became bankers and finance people. Some
Interesting.
people are in the chemistry world, right? Like a lot of what we learned was problem solving,
Right.
and people took that into all the different arenas. And so, as someone who I feel very fortunate, I had a North Star. I really cared deeply for the space industry.
Hmm.
Uh, that's not always the case, and the beauty of getting a engineering degree is that everyone knows you can go solve a problem, and you can really take that and go do anything you want with it.
I had a teacher that really shut us all up with exactly what you just said because there's like the common thing that kids say like, are we ever going to use this in the real world, right? Because that always kind of comes to mind when you're in class and you're doing some obscure weird thing. And anyway, the teacher was like, you know what? Probably not. But listen, this collective education is turning you into like a super logical, rational problem solver that will be able to go and be effective in basically anything. And when I heard that, I was like, okay, that just, you know, that made like satisfied that question for me because it's totally true. And um, I think that's why most engineers or most any engineering degree can be kind of plucked and put into any arena and really succeed. And I think that's why you see a lot of, engineering CEOs, right? Because they're super logical, they're rational, they're good thinkers. So I think, that's just something that you just become, um, basically, no matter what kind of engineering degree you get, which is pretty cool.
Yeah.
So
And
what like, sorry, did you have something to say to that?
yeah, it's just interesting seeing like the world that we live in. Um, I think, in the generations before us, there needed to be different segments of specifically mechanical engineers or electrical engineers. But if you go look at the things that are being built all around us, right? They contain mechanical and electrical and, fluidic systems. And so most
And
of the
you
best engineers I know do a lot of different types of engineering
right.
because it's the combination of those things that really make a successful product.
Yeah. And usually they'll have software too.
Hmm.
True. So, okay. So what school did you go to?
Santa Clara University out in the Bay Area.
Oh, cool. How'd you like that?
I loved it. Santa Clara was a
Nice.
fantastic experience. Great engineering school, perfect weather. Got to, really learn from some of the most brilliant minds in Silicon Valley and, have a full college experience as well.
And what was it particularly about space that kind of sparked you?
It's such an allure, right? It's the vast unknown. I feel very fortunate that we're alive during a period of time that like humans in our lifetime will live and work in outer space.
Yeah.
That has not always been the case, right? People maybe thought that back during the Apollo era, but look at what has transpired in the recent 40 years. Not a whole lot of progress as far as the space industry, and so in the last 20 years, it's really awesome to see all of the space companies and the things that they're trying to do, and that was always such a great allure to me. I wanted to get involved with really pushing humanity to do something that was new and had never been done before.
Yes, I think so as well. It's been really cool to see. It's almost like the last few years they've made up for all that lost time. You know what I mean?
Hmm.
By the private sector kind of seeing like, oh, it's actually maybe economical to go into this.
Yeah.
Have you seen the one? This is just kind of a squirrel moment. Did you see? I can't remember what the company's called, but it's like a kinetic launcher. It's like
Spin
they
launch.
spin launch. Yeah, that one's cool. Do you think that one will go anywhere?
There's a couple different companies that are tackling very innovative launch methods. There's another company that is building a vacuum chamber that is, I think, 15 kilometers long, that is
What?
effectively going to accelerate something on a electromagnetic rail, and it will exit with enough velocity that it could get to orbit. Spin launch is a different approach, right? They have a propulsion rocket that gets launched out of this kinetic chamber and
Yeah.
is going fast enough that it can get a small payload to orbit. I mean,
Yeah, if
I
if you
love.
guys are watching this or listening to this and you haven't looked up spin launch, go look it up. It's pretty wild idea. Um, but it's cool. Okay, so when you graduated, you said you went straight into working on a space plane. Talk about that a little bit.
Yeah. So the company is now called Sierra Space, but when I was working on it, it was called Sierra Nevada Corporation, and um, the plane is called the Dreamchaser, and it is a the size of a small school bus. It fits 7 astronauts and some cargo, and is going to be a transporter to and from the International Space Station. And so when I was there, I worked on the 7 body flaps because it's a plane. As it re-enters the atmosphere, it has ailerons that effectively control its flight through the air, and so it can go land on a runway. And it was, a really awesome experience getting to for the first time in my life, work on structures and the integration of thermal protection systems with those structures. And, taking all of the different systems that come together to form a full plane in this case, um, it was getting, thrown into the deep end of being responsible for a few of those parts and having to integrate with all the other teammates. And so,
So you got
great.
hired as a design engineer straight out of your bachelor's?
Correct. Yep.
Cool. That's awesome. And I guess where is that plane at now? Where is it at in its process?
Yeah, so this is a testament to the space industry. The Dreamchaser still has not flown. They were, I think, are still targeting at some point this year. But
Hmm.
for reference, I worked on that plane over a decade ago. And so
Yeah.
things just move very slowly. I hope to see that plane launch. I know that they're going to get on a Vulcan United Launch Alliance rocket at some point in the future. And, once it has been space certified, people are going to start flying to and from the space station on it.
That's what I was just about to ask was how does it get into space? Is it like one of the Virgin Galactic things or was it on a rocket?
Yeah, it's going to go on top of one of the heavy launch rockets, specifically the Vulcan, which is a rocket based off or from the company United Launch Alliance.
Will it be on like outside like the shuttle or is it going to be in like a container?
Almost all of these, I believe it will probably be in a fairing.
Yeah, fairing.
Um, yeah, and just so it doesn't have to withstand the pressure during launch, but I could be wrong on that. It's been a long time since I worked on it.
That's cool. That's pretty awesome. That's like I mean, pretty remarkable that you were able, I mean, that's what you wanted to go into. You graduate, boom, you're working on, a spaceship essentially as your first project. That's pretty awesome.
Yeah,
So, how long did you work there?
so it was a very short stint. During that period of time, there was a competition from NASA called the CCT Cap Awards, and they had selected three companies to compete for the cargo shipments to and from the space station. And 4 months after I started working there, uh, Sierra was down selected, and Boeing and SpaceX won the CCT Cap Awards. And so 800 people from my company got let go,
Ah,
which, welcome to the space industry. This
yep,
is the way that it works.
yep. Yeah, it's kind of boom or bust
Hmm.
for sure. It's the same with defense in some ways. I work in defense and it's similar.
Hey, I hope you enjoyed the video so far. If you are, make sure you hit that like button and share it with your friends. That kind of stuff really helps the channel continue to grow. And if you're thinking about studying in engineering or any other STEM degree, I highly recommend checking out my book. I wrote this book to fill this huge gap in preparation that exists between high school and college, right? Self-discipline, motivation, time management, stress management, studying performance, and exam performance, it's all in here. Everything you need to get to graduation in one of these more difficult degrees. It's getting a ton of great reviews and helping out thousands of students all over the world. And it's actually been so well received that university professors across the country are starting to require it for their freshman engineering students. So if you're a new student or if you're a struggling student, I highly recommend picking up a copy. It's available in ebook, audiobook, and paperback. I'll put links in the description for everything. Thanks for the support and back to the video.
Um, okay, so then where'd you go after that?
So, I made lemonade out of lemons. I was a ski bum for 5 months. I skied 165 days and then decided it was time to get back into the engineering
Good for
world.
you. So, I think anybody, if you ever get laid off, typically large companies will give you 6, 7, whatever months severance. And I think that's a great time to just go, you know, whatever you want to call it, go on an adventure. And, for you, a ski bum. My buddy that I graduated with, he actually just got laid off, I don't know, last year. And he decided he was going to ride his bike from here, Utah, to like Vancouver.
Oh, well.
And so, yeah, he just went on this crazy trip where he got on his bike and took his skis with him and just every stop, did like the whole backcountry skiing and stuff like that. He actually ended up getting hit by a car on the way home, and that kind of ended his trip.
Oh, geez.
He's okay. It's okay that I laugh because he's okay. Um, anyway, so that's just a long way to say if you get laid off, you usually have a pretty good cushion. So take that, opt maximize that time. So that's pretty cool. So where'd
Live
you
it
go
up.
be a ski bum?
I was at Vail, actually. I was living with a number of other ski instructors in a kind of tiny shared house in East Vail, and got to experience one of the best mountains on this planet for an entire season.
That's awesome. And you were single, no kids, I assume?
Correct. Yeah, I was
Yep.
young. This was, I was 23 years old.
Yeah, yeah. Okay. That's cool. Good for you. Um, that's okay. So I have another story. So when I was in my sophomore year, my dad found some random company. It's called Del Sol. Have you ever heard of Del Sol?
Mm-mm.
So if you ever been on a cruise, and you go into the port and they sell their color changing T-shirts.
Mm.
And if you've ever been on a cruise, you probably know what I'm talking about. Or if you've been to anywhere in like the Caribbean or whatever. Anyway, they're based out of the city I live in, and my dad found this like sweet kind of deal they do where they send kids out to their stores. Essentially, it's like an internship, but it's low paid, So I got paid like $300 a week, but I got to live in St. Thomas in the Virgin Islands for 6 months. So basically, I took 6 months off school just to go live in the Virgin Islands for essentially free, and I only worked like 35 hours a week. It was freaking awesome.
Sounds great.
So if you guys if you have opportunities like that, don't pass them up. Just do it. Your graduation will always be there. Um, there's opportunities and certain places you are in life that I think you should take advantage of, especially when you're single and don't have kids.
It
Anyway,
gets a lot harder the older you get
it's
too.
a
You
lot
gotta
harder. Yes.
take advantage of life. This life is short. You got to make the
Live
most of
it.
it.
Exactly. Okay. All right. So after the ski bum, after the good time, then what happened?
So I went back to the Bay Area. I got a job at Space Systems Loral, a geocommunication satellite production company. And so I was working on the antennas of geosynchronous satellites, effectively designing large carbon fiber structures that were responsible for directing energy from 160,000 miles away from Earth towards Earth.
What do you mean directing energy?
So the way that communication satellites work is energy is getting shot from Earth up towards these objects, which
Okay.
geosynchronous, as a reminder for everyone, means that it is falling around Earth at the same speed that Earth is rotating. And so you can point at the sky and that satellite will always be there, meaning you will always be transmitting energy towards the same places on Earth. And so the satellites that I was working on were responsible for communications, meaning, boat-to-boat communications. Sirius XM had a lot of satellites, right? A lot of these geocom companies are just responsible for transmitting data to and from Earth. And so the antennas, obviously the objective of most satellites is to be as lightweight as possible. And space is an incredibly harsh environment. And so making sure that the energy from where the satellite is, Earth is roughly 16 pieces of paper tall. And so all of the energy that you shoot above or below or to the right or to the left of Earth is lost money. And so we had gigantic, like 3 to 5 meter dishes that had incredibly, precise 1 micron accuracy to direct the energy exactly to different locations on Earth.
When you said 16 pieces of paper tall, explain what you meant by that.
That means that Earth, if you hold your hand out, is roughly 1 inch big. And so the size of the planet from where this satellite exists
Oh,
is very, very small, meaning the
oh, it's
energy
way
is
far out.
precise. Yep.
Okay, gotcha. And then, um, and you designed the carbon fiber part of it.
Yep. And so I was responsible for the antennas, which were typically like 3 meter wide dishes that had a carbon fiber structure on the back. And so,
Right.
the dishes were incredibly accurate and they were made out of a graphite based carbon fiber, meaning that as it went from the sunny side to the dark side of Earth, time and time again, it would be incredibly stable. And so the size and shape of those dishes wouldn't vary throughout the days and nights.
And at the beginning of this, you said low volume stuff. So like, would you build one or two and then you kind of have to move on?
Yeah, so I was there for um, around 2 years, 2.5 years, and I worked on 9 satellites through that entire time. But I never saw one of those satellites get finished. And so typically from the start of a cycle to a satellite getting tested and shipped to launch site would be around 3.5 years. And each of these satellites costs somewhere in the range of $300 million.
Yeah, And then they got to pay to get it onto a rocket, right?
Exactly.
But the satellites are already purchased by a company to be built, right?
Yep.
Yeah, that's crazy.
hmm And most of the satellites would be shared. So, let's say
Yeah,
Sirius XM would
yeah,
own the majority of a satellite, but let's say, one of the four dishes or some of the energy, because there are some amazing RF energy engineers who figured out different ways of transmitting the same energy off of the same surfaces, but in different wavelengths. And so they would share the buses. And so some companies would, contribute to this rather than having a single company pay $300 million.
yeah. Jeez, that's crazy. Was there a lot of competitors?
Yeah, I mean, this was this was pre-Starlink. This was pre kind of the um, whole constellation movement in the satellite world. And so, um, you could think of the big players, the Boeings of the world, the Northrop Grummans as being competitors, but Space Systems Loral really cornered the market in the communication side of things. So non-military, non-defense, but communication satellites in geosynchronous orbit.
And are they still around?
They unsurprisingly have struggled a little bit. They got acquired by Maxar um, in the years that have transpired since I worked there. I think that they are continuing to do it, but the demand kind of in the space industry right now is really moving towards these satellite constellations that are much closer to Earth. They're in
Right.
LEO or low Earth orbit rather than much further away and much bigger satellites.
Gotcha. And so back to the space plane, when you were working on that, was that carbon fiber as well?
No, that was a variety of materials. Yeah, mostly like lightweight aluminum and titanium structures with
Gotcha.
different material around the outsides.
So you kind of had to learn carbon fiber when you went to
Oh yeah,
L'Oreal. Yeah.
big time.
Okay. Cool. So yeah, it's important to note that like yeah, a lot of times when you just got to learn as you go. Um, okay, cool. All right, that's great. So, and then you went somewhere else after that, right?
Yeah. So I left Space Systems L'Oreal really wanting to experience a faster moving company with a smaller team. And so I did some soul searching kind of in the product design world, and I found myself at Airbnb on a very small R&D group for a group called Samara. We were building modular houses, ADUs, which stands for accessory dwelling units, that would get put into people's backyards. And the idea was to leverage kind of the same Airbnb model, but by increasing housing density by putting very small homes into backyards.
That is quite the change. I guess explain that a little bit. I mean, it sounds like you were just kind of over maybe how long it took to kind of see product be done.
hmm
Yeah.
Space industry moves very slow. I was ready for something that was at a higher velocity, and I
Yeah.
wanted, more creativity. In the space industry, there are tons of checks and balances, rightfully so, right?
Right.
Um, and so, each one of my assembly drawings would get signed off by like 25 people, 26 people.
Yeah,
Um,
dude.
you're not moving at a high velocity when you're going through all these checks and balances and
I
having
totally know what you mean.
approvals.
I work in a similar environment. It takes such a long time for stuff to get, started and finished because there's so much stuff that gets in your own way. It's
Yeah.
frustrating, especially when the government is the customer. Um, that's why it's cool to see SpaceX like, for whatever reason they've been able to just kind of say, okay, we're gonna fail a bunch. But that's how, they're gonna move so fast. It's cool to see that.
hmm
It's just really cool to see that. Okay. So I guess let's go into the ADU thing. So what was your role?
Yeah. So I was a mechanical design engineer. I was the fifth person on that team. We ended up over the next 4 years growing to 55 people.
Wow.
And producing a number of different types and sizes of houses. Our original mission was to build a completely modular and zero waste home. And so, um, modularity is one of those really hard things, but we had an awesome opportunity to rethink how buildings are made, which, frankly, is a technology that has not changed much in the past 100 years. And so, a really great opportunity. I effectively designed just about every part of that house. I got to wear all these different hats of, deploying the homes, building manufacturing lines for custom components, working in supply chain. It was such an awesome experience, wearing a number of different hats, getting to, try and fail and learn in all these different roles. And it's really where I fell in love with early stage companies. Even though it was at Airbnb, we were a very small R&D team that literally had its own, very small office. And so it was effectively a startup within a monolithic company.
Yes, yeah. So when you say modular homes, are they like the stuff that I see where the stuff kind of unfolds, or is it where they kind of get snapped together? How does that work?
Yeah, so in the early days, we did a ton of different designs. Since I work there, the company is now rolled out and is their own company, and they're called Samara, Samara. They now take these beautiful homes and they crane them into people's backyards. And so there's effectively a factory that produces, almost complete homes. Those homes get transported on trucks, and a big crane drops it into somebody's backyard.
Gotcha. And this is somebody that's like wants to invest. Essentially, I mean, Airbnb is thinking like, hey, let's get more Airbnbs out there. Let's put them in people's backyards and make them affordable, right?
Yeah, I mean, the idea is to increase housing density.
Yeah.
There is a housing shortage in the world,
Oh yeah.
and specifically in the US. And so being able to increase housing density and allow, folks to have a different revenue stream with the space that they already own,
Right.
or, have additional space in that area without needing to actually go do ground up construction, right? The idea is that this is a shorter system. It gets dropped into your backyard without months and months of construction.
And how much would they cost?
Very expensive. That was, continues to be one of the challenges in the housing world. I think you'll have to go to the Samara website and find out, but um,
What's there now?
you know, plus $150,000 or more.
Oh, geez. Because you see the ones on Amazon or I think Home Depot, you can get them for like 30 grand.
Yeah,
I mean,
there's a
they're
big difference.
probably
This
not as
is
nice. They're
Yeah, this
probably
is
not as
like
nice. Yeah.
very high quality,
Right.
the
Yeah. Or they're
the
probably
nicest
clear.
home you'll find. Um, but there's always an inflection point of cost versus speed versus quality.
Right. And then you still have to put in all the utilities and pipe it and all the stuff,
Exactly.
which is another several tens of thousands of dollars. Um, I think I told you when we talked before, I looked into it for uh, the house that we used to live in, and because we had a big side yard, and I'm like, I could put something here, but some of the cities are getting wise, and they don't let you, use your own land for what you want to use it for anyway. Okay, so how long did you work there?
Yeah, that was 4.5 years. Spent a lot of time there. Was there through COVID, which, Airbnb obviously went through a really challenging time during COVID. I think they lost 80% of their business like overnight effectively. Um, so, you know, an awesome experience. One of the greatest companies. I mean, just an amazing company as far as the way that they care about the world and people. But also, got to see the IPO of Airbnb while I was there. Got to see kind of some of the challenges that they went through, some of the amazing leaders within that company. So, um, you know, an awesome experience. I'm very thankful for it.
Where was that located?
San Francisco.
Oh, gotcha.
Yeah.
Okay. Well, cool. So then that was your last kind of industry job, right?
No. So I
No.
actually went from there to a company down in Austin, Texas called Icon Technologies. They are the ones with 50-foot robots that print houses out of concrete.
Well, that's right. That's right. Yeah. Yeah, I think I'll put the video in here so people can see. Yeah, it's pretty cool.
Yeah, amazing technology. And I got to do some very cool R&D work there. Um, Icon has a space team that is, leveraging the knowledge of robotic construction and won $56 million to print landing pads on the moon. So Icon's going to go print the thing that Starship is going to land on the moon, which is awesome. Eventually, we'll get to the point where we're building habitats up there. Um, and so I did a lot of, early concept designs, R&D work on manufacturing and different, rover concepts, and had a very cool experience there.
Okay, explain how the landing pad and the robot are going to get up onto the moon. Are they going to use concrete or something else?
Yeah, so this was a big part of the research initiative was what is the most cost-effective way to build something on the moon? And purely from a cost basis, you need to use local material. The
Right.
dirt on the moon is called regolith, and that is, in abundance. And so if you can find a way to take the local material and turn it into something, then you're going to be complete. And so Icon has found a couple different strategies, and I believe the one that they're going to send up is a laser sintering process. So taking, power that's generated from some type of power source, probably solar, or you could use, a radioisotope energy, like a RUD, and use that to power a high-powered laser that will melt the regolith that gets scooped up into something that is, strong enough to handle the force of a starship landing on it.
So did you guys have some amount of like moon rocks and material to test?
Yeah, so there was a simulant. There's actually a really big business for producing lunar simulant, which is, like fake regolith. But one of the things that's so interesting about the moon is, here on Earth, we have wind, we have energy because of our atmosphere. And so if you go to the beach or you go to the forest and you dig up the Earth, it will be very smooth as far as like every single atom or, grain will be very rounded. On the moon, there is none of that. And so you have these incredibly jagged and sharp dust specks. And so it's
Interesting.
really hard to take, simulants and produce it like that. And so you can only get, as close as you uh, can with the things that are being produced. And then you have to have kind of a margin for error on what the lunar environment's going to actually be like.
Yeah. That's interesting. I never thought about that where there's no gravity and no kind of elements to smooth things out. That makes a lot of sense. And it makes you kind of scared of, your spacesuit getting ripped open.
Yeah, that's going to be the most dangerous part, right? It's not, radiation will take a long time to kill you. It certainly is dangerous. It's going to be the like little zippers and the cufflinks and
Yeah.
the openings because these tiny little pieces of dust are incredibly abrasive, and that's going to be one of the hardest parts. I mean, there's a lot of amazing commentary out there from the Apollo astronauts of how the doors just never quite shut the same way after they went out onto the lunar
Yeah.
surface.
That's crazy. So, where is that project at right now?
Yeah, I think they have a launch date booked for 2027. So, in the next few years here, things are going to be landing on the moon and actively building up there.
Yeah, it's so exciting to watch. I love it.
Hmm.
Um, okay, so how long did you work there?
Yeah, so that was about a year and a half. Um, and I really left Icon wanting to do my own thing. And so that leads us now to Drafter.
Yep. Um, you say you worked there for a year and a half?
Yep.
So let me ask you this. So did you always kind of have, you know, the idea to go out on your own or, entrepreneurship as kind of your goal? Did you always kind of have that in
Yeah,
the back of your
I've
head?
I've always been interested in it, and really figuring out what my journey was going to be. And I left Icon, knowing that that was really the next step for me. I spent a number of months after Icon purely focusing on trying different things and figuring out what could be my entrepreneurial opportunity.
I was going to ask you that if you had other ideas that you'd pursued before.
A lot of them, and they, this is one of the hardest parts about entrepreneurship is you need to be incredibly flexible. I put myself into a lot of different shoes to see what would stick. I I did a BD role, business development role, as a mechanical engineer, going in, trying to sell things for a different startup. That was a great experience. I thought about, mass manufacturing for some of these other people's projects that I'd, gotten in touch with. I thought a lot about ways that I could improve the space industry. And really, every time you have one of those ideas, you have to take it past the 10 whys and get to a point where, if it gets to that, like, still it has legs once you get through all of those questions of, is this a good idea? That's when you start interviewing other people and
Go
get
into
through
that a
your
little
heads.
bit. So like let's pretend you have an idea
Mhm.
and then let's go through that.
Yeah. So you have an idea. Most ideas, entrepreneurial ideas, I would say are best when you have a deep knowledge of the space. That's not always the case. That's definitely my lens, but
Right.
it certainly helps, right? I spent um, my entire career, over a decade, using mechanical engineering and hardware development software tools and being very frustrated with them. And so, Drafter is a result of all of those frustrations and saying there's got to be a better way. And so, taking these different ideas and, you know, running them through different scenarios of, would this actually help? Would this help just me? Would this help the other people on my team? Great. How much would people pay for this? Right.
Mm.
And going and interviewing people, and at this point, by the time that we, built a full team, we'd probably interviewed hundreds of engineers, mechanical engineers saying, what do you think about these ideas? Is that a good thing? Is that a bad thing? Tell me why.
Yeah.
And if you are sensitive about it, it's not going to end well. You really need to have thick skin and understand that you don't know everything, because you get better through every single conversation that you go through.
Yeah, for sure. Got to be objective about it. Okay, so I think at this point, let's tell people what Drafter is
Yeah.
and kind of what the product is that you created.
So Drafter is a software tool to help the hardware development process. And we're starting by building automation for design engineers to better communicate their manufacturing intent to the manufacturing world. And so, as a reminder to everyone, the way that any hardware good gets made in the modern day is
Hardware is like anything physical.
correct. This could be a bicycle. This could be a missile. This could be a boat, right? This could be a consumer electronic good.
Yep.
Everything goes through this process, which is starts, as an idea, or somebody says, "Hey, we need to go build this thing." They sketch out different solutions, and then they take it and put it into CAD. CAD stands for computer assisted design. I'm sure everyone's familiar with, SolidWorks or Fusion 360.
Mm.
There's 6 big CAD companies, but effectively taking those CAD models, they are now hypothetically perfect 3D shapes. And so, this is where design engineers really live, is they are molding these things until you end up with something that you say, this is it, time to go manufacture that. Now, the difference is, these CAD models are perfect, right? And real things in the world are not perfect. And so you need to create an asset that communicates the ranges of acceptability to the manufacturer. And so the way that the people do this is through the creation of a 2D engineering drawing. You take this 3D object, you create a 2D representation of the different views, and you apply tolerances to those. So if I have a box that's 10 inches by 10 inches, I'll say this box can be 10 inches plus or minus 0.1 inch in every dimension, and the hole that's maybe in the top of it can be 1 inch plus or minus half an inch. And so manufacturer will look at that and say, I need to spend more time on the outside sizes, and that center hole, pretty good range. I can just drill it very quickly. And so this is an incredibly painful part of the design process, and Drafter is building an automation tool that will take that process from hours to less than 5 minutes.
Wow. So you put in a couple inputs that it can just kind of take and intuitively kind of put around. That's cool. Um, I had a thought real quick. So going from 3D model to drawing, if you're a new, how you know that you're a new engineer is that the machinists get mad at you because, you make something that's impossible to manufacture. Anyway, okay, so you how much time does it save? You know, what do you yeah, what are you saving as far as time and effort with
Yeah.
the software?
So this is obviously just our first product. But right now we can save engineers 90% of the time that it would normally take them to create these drawings, and we
Hmm.
can increase their accuracy significantly. So one of the worst things that happens is uh, new engineers will often over tolerance parts because they want their part to be perfect, right?
Right.
They want it to work. But as you increase tolerance, price increases exponentially. And
Yeah.
so, one of the worst things that happens to new engineers is they will over tolerance parts and they'll pay way too much for what they actually need it for. And so, one of the beauties of our tool is that we help you find that Goldilocks range of what you're actually trying to achieve with this part and what the tolerances for all of your different features should be. And so we take, all of the guesswork out of this process that has no checks and balances today, and we save engineers time and drastically increase their accuracy and communication.
That's interesting. And then is it an on like a downloadable software? Is it like something that you guys host
Yeah, so this is a cloud-based software.
and so
Uh,
it can improve?
Yep, you go to our website, you bring your step file in, which is a universal export from all the CAD systems, meaning we can work with every CAD system today. And uh, all of your drawings get created within the Drafter platform. And so that means that you can go back in, you can update those things because as most engineers know in the hardware world, things are iterative, right? You don't get it right on your first time. You send it to the manufacturer. They say, hey, there's no way I can drill this hole, right? You need to continually update this. But every time you change that part, you need to make a new drawing. So Drafter is taking all of those cycles and repetitions and making them, happen instantaneously.
Gotcha. That's super cool. So I want to get into so you back to when you had the idea. Like what, you know, the process where you said, okay, I had this idea, and first of all, it sounds like you kind of had this slowly building annoyance with creating drawings over the several years that you worked, right?
Yep.
I guess what was the thing that kind of triggered the idea for you?
Yeah. So I have a co-founder named Peter, and I would recommend to anyone that wants to get into entrepreneurship, find yourself a teammate or teammates. It's just so much easier to do all of the challenging things that you need to do when you have other people to help you. Peter and I started, really putting our heads into this and figuring out where the opportunities were. And, he's a software guy. He was effectively interviewing me saying like, what were the worst parts about your job? And we kept coming back to all these different things, right? There's a number of different challenges within the hardware development space, but this concept of communicating design intent is incredibly critical because most ecosystems are not, full stack, meaning there's a design world and then you use external manufacturers. And so there's this moment where everything needs to get communicated. And that communication is a huge opportunity to have things get misinterpreted
For
or
sure.
confused or not communicated correctly. And so, it was kind of a number of different uh, moments of like, aha, this is both one of the worst parts of mechanical engineers' jobs, right? We've interviewed hundreds of engineers, and 9 out of every 10 engineers say that creating 2D drawings is like the worst part of their job. So we're helping them solve that problem, and we're improving the overall process for creating that object, whatever it is.
Yeah. Gotcha. And then, so you said you had a software guy. That's a pretty cool partnership where he's like, all right, I want to make software. You tell me where the problem is to make software around. That's pretty powerful. So you interviewed hundreds of people, and then ultimately you were convinced, like, okay, we want to fill this gap. There's a gap in 2D drawings. We want to fill this gap, um, and essentially saving time, right?
Saving time, improving efficiency for teams, right? When these mistakes get made, they are incredibly costly. People are losing hundreds of thousands of dollars to junk parts because they missed one little detail that
Yeah.
renders it from being usable, right? And so there's lots of warehouses full of scrap metal that just like you can't use because it was either manufactured incorrectly, right? And it's a real shame and it's really expensive and it makes timelines slip.
How long ago did you have your idea?
Yeah. So, this was really the middle of last year. And so, um, maybe 14 months ago, in August of last year, we raised a pre-seed amount to go build a team to effectively go build this product out and get an MVP into the world. And then we
What is
emerged
that?
from stealth. Say it again.
What is that MVP?
MVP stands for minimum viable product. This is
Got it.
like, hey, I have an idea. Let me prove to you that I can, one, go build this thing, and two, like prove that people want it rather than having them say it.
And who did you go to raise the money?
Yeah. Um, we went to a number of, venture capitalists who are in San Francisco, kind of, um, big game people. My co-founder also came from the venture world, and so we have a lot of
Okay.
relationships
I
there.
was just about to ask how you got those kind of meetings set up. So he came from that. So you already kind of had an in.
Yeah, a big part of, entrepreneurship is networking,
Right.
is, there is an abundance of information and knowledge out there. People have made the mistakes that you could make, and you really need to go figure out what they are. And a lot of people want to help you. And so getting, leveraging your network, figuring out who knows people, uh, building a vision, and then asking people to introduce you to VCs or other customers, right?
Yeah.
It's a big networking game, and that's a big part of what I do every day.
Sure. Totally. And how did you meet your partner?
Yeah, he actually found me online. He was exploring entrepreneurship as well and was starting to interview engineers. And I was one of those people that he interviewed for an early concept he had. And I feel kind of bad. I shot his idea completely out of the sky, but we've been working together ever since. So, uh,
Yeah.
a good start.
Cool. So, and then how many people are on your team?
Yeah, we have a team of 6 right now.
6. So how was that process? How was hiring, because I feel like those first people are super crucial, right? And you only have so much money.
Oh, yeah.
So what was that process like? Like hiring people and convincing yourself that they were the right people for the team.
hmm Hiring is incredibly hard. Finding people who, are the right type of crazy to come join,
Right.
a nobody, right? I was a mechanical engineer. I have no track record of being an entrepreneur, and, you know, telling the right story and finding the right people to, believe in that story and leave their perfectly great jobs, right? These people are incredibly intelligent. We have a fantastic team, um, to come join this crazy mission. And so, I feel very fortunate. We found a lot of people online. We got, networked our way. We really left no stone unturned. We reached out to hundreds of people, on GitHub, people who had contributed to different open CAD type projects, and ended up with our awesome team.
And it's just like more software engineers or
Correct.
yeah, cool. That's awesome. So I guess explain kind of what life has been like the last, year. Has it just been pretty crazy or fulfilling, tiring? How's it been compared to what, job life was like when you were in industry?
Yeah. Best job I ever had, um, hands down. I'm working far more than I maybe ever have, to kind of within context, but it's different when you have ownership, right?
Right.
I care so deeply for the vision, for what we're doing, and we really have an opportunity to truly create a difference in the way that hardware is built and designed and developed. And so we want to be the reason that, hardware is designed much more efficiently and, with less people and cheaper parts 5 years from now. And so we have an awesome wedge in the way that we're going to get there and the big vision of truly changing the hardware development process. But we have to take baby steps. And so it's, finding early customers, finding people who feel the pain of what we're solving today, and learning from them and finding design partners and having them, give us feedback constantly on what we're building. We are truly like having the jet take off as we're building it.
That's the best way to do it.
Mhm.
The most stressful, right? So, is that where you are right now? Is trying to find your first customers? Is that where you at right now?
Yeah, so we have early customers. We just emerged from stealth a few weeks ago, and
What does that
you know,
mean?
um, some startup companies, rather than announcing who you are from day one, will operate out of stealth mode, and so that means that you can work under the guise of secrecy just to be able to not necessarily be out front, and still be malleable, continue to change things, and then use this opportunity to announce, what you're working on to the world as an opportunity for people to find out about you, and then eventually get to the point where, people are coming to our website and signing up almost on a daily cadence at this point. So leveraging that opportunity to have people find out about us is really an awesome thing.
When you say people are coming, is that businesses are coming?
Mechanical engineers working on hardware designs at, you know, any number of type of business.
Gotcha. And then it's a subscription service, I assume?
Yep. So seat based, we're selling into teams,
Gotcha.
and really, we are the one stop drafting solution. We help people with GD&T, which stands for geometric dimensioning and tolerancing, and we get them from design to manufacturing far more efficiently with much less time and energy.
So GD&T, for people who aren't aware, is like a universal language for kind of how to communicate, you know, geometric stuff on drawings, right? And I think most, if you go into mechanical engineering, if you're lucky, you'll have a class. Your company will teach you about GD&T, but it's not cheap. But that's so you're saying what you guys do is that's kind of baked in.
Yeah, so GD&T is one of these crazy things where I interviewed a number of college students a few weeks ago, and um, they had a quarter-long class on learning to use CAD. In the 10 weeks, there was 1 week that was dedicated to making drawings, and during that week, there was one single day that they talked about GD&T.
Yeah.
And, that's crazy. This is a thing that effectively means that your first employer or some employer is going to be responsible for educating mechanical engineers on the best way to communicate design intent to manufacturing. And so, a real, missed opportunity. So we're taking that on ourselves to give education away for free. Obviously, we're automating these drawing creation, but we need engineers to understand what they are actually making decisions on, what the tolerances mean that they're choosing to make. And so we're building education tools. You can go to our website, drafterinc.com, and find a number of articles that we're writing on the subject matter. We have a lot of content that we're producing right now that's going to keep continuing to come out. And frankly, if anyone has questions on this, please reach out to me. This is like one of those things that needs to be educated throughout the industry so that everyone can work more efficiently.
And how can they reach you?
Yeah, you can find me on LinkedIn. My name is Chris Barton. Uh, Please reach out, shoot me a message, connect, tell me that you found me on this podcast and would love to chat.
So back to the school stuff. So like what advice do you have for, current students as far as like maybe things they can focus on, or, maybe you have a student that really wants to is very interested in entrepreneurship and kind of starting their own thing. What kind of advice do you have for them?
Yeah, I mean, the reality is every single thing that you want to learn exists on the internet today. You don't need to learn everything from college. There is an abundance of information out there, and you need to put yourself into a position where you want to go learn these things. And so figure out how you learn best, figure out how you problem solve, and figure out what you want to go work on. And, if you get a job and you don't like it, you're going to learn far more from that experience than never diving into the pool. So, um, yeah.
I think that's a good point, right? Like what you did is you went and kind of jumped from job to job to job to job, experience, 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 and you learned a lot, but what you did learn is where there were gaps that could be filled, right? And I
Yeah.
think that's really important. Is just to go, is not to hesitate so much. I think, you know, I think that's an important thing, is to go, because like you said, it's important to be an expert in something before you. I mean, you don't have to be, but it's very beneficial to be an expert in something before you try to create in that space.
Hmm.
You know,
Yep, to
so
have context. I mean, if you understand a problem deeply because you've experienced that pain, it positions you better to be the one to come up with a solution for it
right,
because you don't need to go interview people, right? Like, I wish I had Drafter every single job that I've worked at.
that's
And
cool.
I look forward to giving that to every mechanical engineer that comes behind me.
So okay, so you said you got people signing up right now. So what's the next step with the company?
Yeah, it's time, to grow. We obviously, we're in the early days. Our product is new and getting better every single day. And we have a number of other products that we're building. And so we're going to expand from single parts to ingesting full assemblies to eventually doing tolerance stack up analyses. Um, there is a lot of opportunity for this information that today currently exists as pieces of paper to move into the digital world. And so Drafter is going to be the reason that, all of these manufacturing worlds really go from uh, analog to digital, and we want to be the change in that entire industry.
I guess this might be a stupid question, but when you go onto the Drafter's website to use the tool, as far as security goes, because I'm thinking of like a defense contractor, some other kind of high security company, I can see there being some questions like, I don't know if we should be uploading our models to some other tool online. So is that all good to go?
Yeah, so we work at the highest level of security that's effectively possible on cloud. All of our data is stored on AWS GovCloud, which is effectively the government side of cloud storage data solutions. There's also the availability of taking Drafter and putting it on-prem. So most of the defense contractors actually have their own servers, and when they purchase software, it gets placed into kind of its isolated system and operates there. So a number of different opportunities, right? We need to serve everybody who is designing hardware, not just people who are
Right.
in the defense world.
So you're saying it's possible to kind of take it offline and use it. Gotcha.
Yep.
Okay. I got you. Okay, cool. That's awesome, man. That's pretty exciting. So I guess what I'm thinking of, like, you know, new engineers who want to start something new but aren't really that confident. I guess what gave you the kind of the confidence to just take the step and say, okay, let's freaking do this.
Yeah, I mean it's scary, right? It's stepping into the void. Um, do it. Like you just have to do it. It will never get easier. There's never going to be a time where it's going to make more sense. Go get some experience, figure out what you like, what you don't like, um, but make the jump because the reality is startups are prone to fail. There's more failed startups than successful ones. But if you never experience that, you know, you're just going to be a cog in the machine, which is perfectly fine. But if you're going to have regrets about that, like there's only one way to jump, and that's just doing it.
Do you think you'll ever go back to anything but entrepreneurship, like kind of doing
I
your own
love
thing?
this job.
Yeah. And
Yeah.
and since you started, have you had like other ideas that you want to pursue?
Now I think rather than other ideas, there it's an understanding of how the process works, right? It's now all of those other ideas. It's like, I see the steps that I need to take between A and B and C and D. Um, and it's all possible, right? If you're
Right.
tenacious and you're a problem solver, there's lots of ways to get there. Um, but it's going to be hard work. And so figuring out kind of what those steps are. And the reality is like people really do want to help. And so don't be afraid to ask for help, ask for advice. A lot of informational interviews, right? People have done this before. Go learn from their pain and their experience.
Right. I think that's a good point. Like, because I think is what scares a lot of people away, is just the unknown,
Hmm.
right? They just say, "Oh, I don't." the pathway is not clear and not well laid out before me really, so I'm kind of scared because I don't know what step to take, you know. But because you've kind of tread through it and learned, uh, you know, it almost gives you a lot more confidence. Like, okay, I can see doing this again. It's almost like, um, you know, those types of games where you uncover the map as you go.
Hmm.
It's almost like that, right? And then, you know, it just that's all you can do. Is just kind of uncover as you go.
Hmm.
And then no matter what, you're going to learn something for sure. Cool. Well, sweet man. I think that's really all I wanted to. Did you want to cover anything else?
No, I think this is good. We
Yeah,
checked a lot of the boxes.
I think it's really cool. I think you know your story and your where you are at is going to be really interesting and kind of inspirational to a lot of people. So I'm happy to have you on. Okay, thanks, Chris, for coming on. I think people are really gonna, I think, be inspired and really be entertained by your story. And let's go over again where they can, you know, contact you and learn more about your stuff.
Yeah. You can find me on LinkedIn. My name is Chris Barton. I'm the CEO of Drafter. And if you're interested in checking out the product, you can also get a hold of me through the Drafter website, drafterinc.com, drafterinc.com. Would love to hear from you if you're ever interested in GD&T or entrepreneurship or really, anything that we've talked about today. Would love to get in touch.
Sweet. Well, thanks again, Chris, and we'll talk to you soon.
Thanks, Jake. Appreciate you having me.
There you guys have it. I hope you guys found that pretty interesting, valuable. You know, I found it really inspirational and just kind of showed where an engineering degree can take you, right? All the way from working on space planes, satellites, 3D printing houses, and then working your way into entrepreneurship. I thought it was a really good example of just where, you know, an engineering degree can kind of take you in the world. So let me know what you guys thought in the comments below. And if you have any questions for Chris, you know, I'll put his contact information in the description below. But until next time, thanks for watching, and I'll see you in the next one.